Hey guys, and welcome back to part 3 of this series of how to make your own macro keyboard. And we did it. We finally made a keyboard that I can use for Altium, I can use for KiCad, and I can use the same buttons, and that will give me the same place wire, it will give me the same place component. I don't have to get confused anymore. Do I push R for rotate? Do I push spacebar for rotate? How cool is that? So in this video I'm going to show you guys not the full program, so the program how to make the keypad work, how to make the HID of the key and the keypad together, and the screen, the OLED screen, the 128 by 32, how that's going to work. So I did have to do some hacking with the STM32, but that was fun. So next video, part 4, will be the final video of the LEDs with the housing, with the noise detection, and just the whole thing working as planned. But it's working now as a keyboard. This is probably one of the most useful designs that we've made for me personally, because when I do PC design, going between KiCad and Altium and all the different programs, I do push the wrong buttons, but now I can push one button and it'll be for all. So yeah, if you have not watched part 1 and 2 of these videos, I would just suggest to go to part 1 and part 2. So in part 1 we speak about the schematic, about the PC design, the Gerbers, things like that, the circuitry behind it. And then part 2 was about how to get the firmware on the STM32F, how to integrate it with Arduino, and how to get the USB working with drivers and things like that. So if you haven't watched those yet, when I talk about the libraries, you might not have it because you haven't followed those steps yet. So just go back to part 1 and part 2 if you want to learn. If you just want it to work, yeah, I'll give you the code below. Just use it. I don't mind. We're all different. We all have different reasons. I'm going to make the Gerbers already available on GitHub. I'll put the GitHub link below, the PC design files. I'll add the code to the GitHub as well. I will update it. If there's anyone in the community who wants to improve the code, please feel free to do it. Let me know. I'm not a programmer, so I enjoy just bringing my ideas to life. So the PCB design aspect about it, and I know how to put things together to make it work. But my code is not efficient. It is not. What I would like to do is have an interface where I can change the keys, because currently the keys are hard-coded. It's not ideal, but it works for me because I know what I want in Altium, I want in KiCad. But you might want something else. Then you'll have to go into Arduino code and change it, which is not ideal. So if there's a programmer out there who wants to update it for me, please let me know. I'll be grateful. Maybe a nice GUI interface on the computer where you can just type in one, I want this to do this. But yeah, let's get started. I've been chatting too long now. Let's see this work. Hey guys, so as I mentioned earlier, if this is the first video watching, I would advise you to go to part 1 and part 2 of this video, because in part 1 we discuss about this PCB, about the schematic, and what we're actually trying to achieve. And then part 2 is actually how to put the firmware on the STM32 so that we can use the USB and the libraries and so on. If you haven't done that yet, some of this information might be a bit confusing, but I'll try to make it so even if this is your first video, you can understand. But I would strongly advise to watch the first and second one. So this keyboard I'm going to break into 3 different aspects today in this video. The keyboard, which we're going to make as a keypad. So the keypads you buy from Arduino and stuff, similar concept. And then the second one is the screen here, is an OLED SSD 1036. You guys are quite well aware of it. So how are we going to program that and how to make it STM32 compatible? I kind of had some trouble with that. Yeah, I had to do some hacking, but it's fine. I'll show you guys. And then the last one, but not least, is how to take a keypad and actually make it like a HID, a human interface device, so you can use it as a keyboard for the PC to see. So when I push a button, it can be a control or spacebar and stuff. So that's what we're going to do in this video. Break it up in 3 sections. Code by code by code, and then how I put it together, and then yes, you should be able to have your own macro keyboard. I will speak about the LEDs and the noise detection device that we created here on another video. I don't want to make the videos too long. Yeah, I want you guys to understandable chunks. So LEDs and the noise pickup with a mic will be in the last video with a housing and the complete structure. And then, so after part 4, we should have a fully built macro keyboard. This is already functioning, but fully built. So the first section I want to talk about is the keypad section. So a keypad you can normally buy from your local Arduino shop. It basically looks like this. So this is a 4x4 matrix keypad, but what we created was a 3x3 matrix keypad. So that's what I'll look at now. Some of you are aware of the KeyPad library in Arduino. This, however, does not always work with the STM32. So I will share the link below of a library that I found that does work with the STM32. So normally you will go here, manage libraries, install KeyPad. That library will give errors. So in your documents Arduino folder, there's a libraries folder. Paste the KeyPad directory. You can see it's a bit different. Inside this, I will share the link where you can download, and then everything should be fine. So if you go File, Examples, and at the bottom here you can see KeyPad, Custom KeyPad, you'll see something will pop up. Always just push Verify to see if everything is fine. Done compiling, that means it is fine. So you will see that it's mainly used for the 4x4 matrix. So what we want to do is make ours 3x3. As you can see, we have 3x3, and I created a matrix structure like this. This was more explained in part 1 of the videos. So we just want to make this 3x3. I like to make it 1. There we go. And as you can see, rows and columns, that should also be 4. This is your pins on your Arduino or your ESP32. In our case, the STM32. So what we're going to do is just have a look at our schematic. We are linked to our row 1 is PB0, row 2 PB1, and row 3 PB2. So that's what we do here. So we say PB0, PB1, too much, and PB2. So it's rows PB0, 1, 2, PB0, 1, 2, and my columns are PA4, 5, 6. And that should be it. So we made it 3x3. We said what it should be when I press it, so that should be fine. Let's just test it. So what this actually will do now is when I push a button, it will get the custom key with this function and just print whatever button I push. So let's see what happens when I upload it. Push upload, then I'll go to serial monitor, and let's see what happens. So I've got it over here, and I'm just going to push buttons here, 1, 2, 3, and as you can see, it's popping up 1, 2, 3, 4, 5, 6. So that is pretty good. So that's it. That's how easy it is to make your keypad from our PCB. I will share the files, the H header file. So this is exactly how you to change it to make it work with our PCB that we created together on our live stream. Let's have a look at making this a HID. Now let's look at making an HID. So I'm going to always use examples. So it's a good start. If you just want to build it for experimenting and learning, don't be scared to use examples. You don't really have to rewrite everything from scratch with the love of Arduino. So you'll see examples. I've got examples of generic. So this is done in video 2, where we took the folder of our STM32F1 and pasted it into a hardware folder. So please watch that video if you do not have this yet. And then underneath here you can see USB composition. So in USB composition for STM, we just say sample keyboard, and you'll see something like this pop up. Let's just verify to make sure everything's fine, and then you'll see we will use libraries called USB composite H. So this should be already fine once you install the bootloader folder that we discussed in video 2. So this code here, all it will do is just keep pushing hello world to our PC. So the buttons won't interact with it yet. It will just be like, here we go, hello world. But what we actually want to use is keyboard.press. So keyboard.press is an Arduino library where you can just use real keyboard keys and it will happen on your PC. So like F1, F2, cap locks and things like that. You can also go keyboard press P and it will simulate a push of P on your computer. So this is not exactly what we want. We want to use keyboard press. So what we'll do is we'll remove this and just say keyboard press. So what we also have to do is release the keyboard after we do something. So if you just do keyboard press without this, the IC will just keep pushing P, 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 P. And we don't want that. So what this is going to do now is just go every, I think it's almost 10 seconds. Let's say 1 second is just going to make P on the PC. So let's see if this works. I think it's important to note, once you upload a HID, you will lose perhaps your port. Don't worry too much, it does happen. And now it's uploaded. Now let's see. So there goes P, B, B. So I'm not pushing any buttons. All it's doing, my microcontroller on my keyboard is sending a command to my computer, push B, push B, push B. Now let's see how we can combine the two. So we're going to combine our keypad and with this HID to make it, when I push a button, do something on my PC. Let's have a look. So as you can see, I made a macro keyboard Arduino code and I took over HID headers, the keypad headers, and the same that we just saw now, the rows 3, the numbers. So this is exactly the same as we did the first part of the video, and then that's the same, and now you can see the HID keyboard begin, that's also the same. So I just copied examples we had and I'm putting it together to make something that I want. Like, I'm not a real big programmer. Yeah, I just use what I can to make ideas in my head come to life. So don't judge the code too much. It's literally just putting it together to make it work. It's not efficient. So hopefully someone out there in the community can take this keyboard and write some proper code to make it even more efficient, and we can share it with the community. That would really be amazing. So what we're going to do now is same, get the custom key. So now what I do is I create a case. So case is just if it's 1, so if this mode is 1, then behave like something. So in my example, I want for Altium and KiCad, PCB and schematic. So that's why I've got 4 modes. I've got the Altium mode and the KiCad mode for the PCB and schematic. Don't worry too much about this. I'll discuss that after this about the screen. So all I do now is with custom key 1, I make my keyboard press P and N. So in Altium, that is place net label. So that is keyboard release, and then if I push 2, which is the second button on my keyboard, then I want the PC to be PW, which is place wire. I did this, so if I go to mode 2, or let's say mode 3, there's my KiCad schematic, and then if I want to push the net label, I push L. It's not the same keys, but for me now, when I push one button, it'll be the same for both programs. The same with 2, W, because that's wire, and A for place component. So I can change this to adapt to the program I'm busy using. So it's the same. So we took the example of HID, the press example, and then we took the example of the keypad where we say, okay, if it's 0, you can do something, and we combined these two to create our macro keyboard. How cool is that? So I've got just and you can add as many modes as you want, make use of a case statement, and then I just used pin number 7 or button 7 to toggle between the modes. If you look here, so if I get 7, I just toggle between the modes. I should have maybe had an encoder or a potentiometer or a switch to toggle between it. That maybe in version 2, then I could have made use of the extra button. So for now, when I push it, it just toggles between my modes. I will share this, guys, but as I said, I'm still going to do some updates with the LED and the noise maker circuit or noise capture circuit. So if someone's behind you and they're making a noise, your LEDs will flash when you're gaming or something. Now let's have a look at the screen, because this was quite an interesting part and some hacking had to be done. Now let's have a look at my screen. As always, I'll go to my examples, file example, and in the bootloader and the programs we copied from video number 2, we'll see at the bottom here we've got SSD 103 and we choose the STM32 and it will pop up. Now initially when you do this, it might not compile, it might say the STM32F error. Just make sure that you installed your Adafruit GFX, and also very important is when you go to board manager, install the SAMD boards. So we don't actually use the SAMD, but the libraries in the Adafruit SSD1306 and the GFX actually uses libraries from this board. So it's a bit of a mix match thing. So it's very important to install this board, otherwise it will not work. So once you do that, you need to change that it's a 128 by 32. Our example is 128 by 64. To do that, you have to go into the header and C++ file of this library. To do that, you go Sketch, Show Sketch Folder, and then you go Adafruit, and here it is. So what I normally do is I use Notepad++, and I just drag it like this and this. So things you have to change. Here at the bottom, you can see you got define SSD 12864. So this is default So I commented this out and I uncommented this because I've got a 12832. So if you've got a screen 12864, then leave it as is. And that's all you have to change on the header file. Now when you go to the C++ file, be sure to write this code. So when you look at my schematic, I actually used PB10 and PB11, which is actually the I2C2 and not I2C1. So it's not the default I2C. I should focus more, but anyway, it works. So we have to write this code, 2y, y2. So I'm saying use I2C2. So this is actually a hard I2C, not a software I2C. It's actually built in the IC, you're not bit banging all that stuff. So all you have to add is y2. I define y2 as a 2-wire, and then there we go. That should be fine, and that's all you have to do. And then you can just push save. I've already done it, and then you should be able to verify it. That's another problem. So you can see here, if FSD height, all you have to do is delete it. I'm not sure why this code is here. So the code just says if it's not a 64, but we have a 32, then yeah, give me an error. Let's just do that. There, done compiling. Now let's upload. And there you can see sometimes it does give some errors at the bottom. Don't worry too much, it's because it's going DF mode. But there you can see it is running nicely. Just example on the keyboard. There we go. So there, that's it. So that's how you can get writing. But now what we use is only the text of it for my Arduino for my Altium and KiCad. So you can write different images and stuff, and I'll put the KiCad logo on it and things like that. But for now, I'm just using the text function for this to know which mode I'm in. Now let's look at the whole code together. Now what I did is I just took all three of these aspects we spoke about in this video, and then just brought it together in one Arduino programming file, label it macro keyboard. I will share this file as well on GitHub with link below, but I will add to it and push more to the Git server. Anyone's welcome to take this code and improve it. Like I said, I'm not the best programmer in the world. So what we did is we just defined the same libraries for the screen, for the HID, for the keypad. And all we did now was, like I said, toggle between modes, and depending on the mode is depending what I do. So I will write to the screen, Altium schematic with the print line display. So all you have to do is clear display, set the text size, so 2 fills it quite nicely. You can choose the color, set the cursor, so this 00 will begin at the beginning, so you can actually set it where you want it on the screen. Do you want it in the middle, do you want it top, bottom? And then I print a certain text to the screen, and then I display it. So you have to display it before anything shows up. And then I will just toggle through it. So when I push 1, I will place a net. When I push 2, I'll place a wire. When I push 3, I will place a part. So when you have 2 text after each other, you have to release it in the middle, because once you push P, it will keep pushing P until you release it. So you can't do a double P without releasing it first. So we had to release it and then P. So you'll see the difference compared to the others. And then if I want to use fun stuff like real keys on the keyboard that is not letters, I can use things like key escape, key F1, things like that. Control also here somewhere. Key F8, there you can see key left control plus H. That is to place a port on KiCad. So yeah, it's just going through it. So, and you can add it more and more at the bottom here. But that's just the principle of it. I will improve it, and I will add the LEDs and the noise maker like I said. But I will share the code with you already so you can maybe use it. So let's see if this works. I know it works. So let's upload it. There you can see I just kept outdoor food, and there we go, Altium schematic. So when I push 7 will pop actually, it will toggle through it. KiCad, Altium, PCB, like this. So what actually happens when I go to KiCad, so I'm on KiCad, Altium schematic. So this button here is escape. And now I want to place a net label. I just push this button and I've got a net label, escape. Push this button, I've got a wire, escape. Push this button, I'm going to place a component. Now I want to go to KiCad, there we go, escape. Push this button, I place a net label. Push this button, I place a wire. How cool is this, guys? And if I push this, I should place a part. So it doesn't matter if I go between KiCad or Altium, I can use the exact same buttons And yeah, you guys can change it to what you like. So in schematics, I use wires and net labels a lot and place parts. Also power ports. I can also update straight away. So with this mill point, I'll update the PCB on both programs. This one is a power port. And also what I get confused with a lot, or not confused, I use spacebar or R on different programs. So in KiCad, R is rotate and spacebar is rotate in Altium. But now I don't have to worry about that. I can just highlight something, and I think it's this one. Yeah, so it's this button here. We'll just rotate it, escape, and when I go to Altium and I highlight something, I push this button and it will rotate. So the same button, same function. Never get confused ever again. And that's it, guys. So I'll still work on this, and then we will take it further. We'll get the LEDs working, make housing, and yeah, get the sound detection circuit also work that one of our subscribers wanted us to add. And it was real fun building this together with you guys on the live stream. But let's make it better. And that's it, guys. It's a bit long video. Sorry about that, but I didn't want to get any confusion. I just want you guys to know exactly why we're doing what we're doing, and just how you take examples and put it together. It works. We live in a great community where people are freely putting available things so you can make use of. So make use of it. So I'll put the design files on GitHub and the programming link below, and let me know what you guys think. What next projects. Also, guys, just remember that we are doing once a month a sponsorship, so either financially or supportive, or so watch a video we've made about a week ago where once a month we'll choose someone that will help through a project. So it's really just because I understand that not everyone can afford Arduino, cannot afford a Pi, cannot afford PCBs. So if you have an idea that you just want to do, let me know in my emails below as well, and then we can see if we can help you. We will choose one a month, so it's not a competition. It's about who we think we can help the most and give most value to. And on the other side, we also, because Blindbot's monetized now, sorry for the adverts, we also have a join button below now. So now you can join the Blindbot membership. So it's just a small appreciation for what we're doing. It helps us just help you guys. So I will use that to sponsor the projects as well. So I want to use the monetization part of Blindbot to help more people. So yeah, just putting it out there. Of course, I will always give free advice, free help. So don't feel bad if you don't join. Don't keep anything against you guys. I started this to help everyone, especially the people who can't afford help. So it feels weird, right? I was getting money, and then yeah, I don't want to start a thing where people pay to get help, because that's not the point I want on this channel. I want to help the people that really can't actually afford to get help. But anyway, I'm just mumbling too much now, guys. So yeah, part 4 will come probably next week, hopefully, and then we should be done with the macro keyboard. Then we'll move on to a next project. Let me know in the comments what you guys want to do next. So many ideas, but something that's interesting to you guys also learning. Okay, I mumbled too much now. I'm just chatting, having a good time. So yeah, guys, we did it as a community. If you guys want to really go in depth, you can rewatch the live streams we did for this project. But yeah, I do make shorter videos to explain it in detail. But we actually built this on live stream Sunday, PCB Design. Still going strong. Okay, guys, have a fantastic week, fantastic weekend wherever in the world. Until next time, stay safe. Bye.